Jai Hind to everyone. Myself, Dr. Rahul Kumar Pandey, Assistant Professor in Applied Science Department in Kumar Engineering College. Today, I am presenting a lecture in application of partial differential equation, which is covered in Mathematics 4 in AKTU syllabus, evaluation scheme in BTech second year students. Okay. Now, topic is method of separation of variable with example. Necessity for this method for solving a partial differential equation with boundary condition, like one-dimensional heat equation, one-dimensional wave equation, two-dimensional heat equation, Laplace equation, which is mainly covered by this method. Okay, so method is very important for solving such type of complex equation in mathematical point of view. Generally, we have knew about in physical background what is heat equation, wave equation, and Laplace equation. But in mathematical point of view, we have solution in the form of partial differential equation, and we use method of separation of variable for such type of complex equations. Okay, now look at in this. What is method? Define method. In this method, we assume the solution to be the product of two functions, which involves only one of the variable. Because we have to know that in partial differential equations, there are two types of variables, dependent variable and independent variable. When independent variable is more than one, then partial differential equations occur. So that's why in this method, we assume the solution, product of two functions, each of which involves only one variable. Now, we have discussed by example what is actual phenomena for solving this methods. Use method of separation of variable to solve the equation del u upon del x, 2 del u upon del t plus u. And as we discussed, condition is important. Here condition is ux0 equal to 6 e to the power minus 3x, which is the initial condition. And here equation del u upon del x, 2 del u upon del t plus u. Here u is dependent variable and x and t are independent variable. The solution of this equation in the form of curve u equal to f of xt. U in the form of xt. So in this method, we assume the solution to be the product of two functions, each of which involves only one variable. So we assume solution u of x into t of t. Small x corresponds capital X and small t corresponds capital T. We assume the solution. Okay. Then put the solution in given equation. Del upon del x xt equal to 2 del upon del t xt plus xt. Okay. Here in left hand side, we operated the partial derivative here xt, where x is a function of small x and capital T is a function of small t. So that's why here we partially differentiate with respect to small x. That's why t is a constant. In right hand side, small x, capital X is a function of small x and capital T is a small function of small t, and derivative is small t, means capital X is a constant and constant remove outside, and equation is 2x dt upon dt plus xt. Okay, like this. For separating the variables dx are x and capital T is t, so divide xt in whole equation. Divide xt in whole equation. xt and xt, tx and xt, 1 upon x dx upon dx, 2 upon t dt upon dt plus 1. Now, for separating the variable 1 upon x dx upon x, 2 upon t dt upon t plus 1. Now, solving the equation, we have to find the curve u on xt, and here we assume the solution in the form of u equal to xt, means x of x and t of t, but here we have to see that equation is only one and variable is 2. So how to solve this equation? Because we have know that for solving such type of equation, number of equation and number of variable fixed, but here number of variables 2 and equation is 1. So it's more difficult that we choose an arbitrary constant like equal to k, and constant may be k, p square, anything you have to take in. Okay. Now, like here he is taken minus p square a fixed parameter for one dimensional heat equation, wave equation, so that anything you have to take, k or p square, nothing matter. Okay. Now, for solving such type of equation, let's take one by one. Firstly, we have to take x dash upon x equal to k, means dx upon x equal to k, dx upon x k dx. Integrating both sides for separation of variable, dx upon x log x kx plus log c1. Now, constant may be taken as anything. Function is log x, so that we are taking constant in form of log. Okay. Up to function here we have see that two function in the form of log and kx only algebraic function. Log we treat as in the form of log x, log form. So we have converted log e of e kx plus log of c1, because log e of e, value of log e of e equal to 1. We know that log e of e equal to 1, so that we have taken kx in the form of log e of e. Okay. Now, log a plus log b equal to log ab, so that x equal to c1 e to the power kx. First solution has come out. X in the form of small x. Here we have used only method of separation of variable in the ordinary differential equation. Also, another method for solving of such type of equation, 1 upon x dx upon dx equal to kx, so dx upon dx minus kx equal to 0. This first order differential equation, d minus k of x equal to 0, m minus k auxiliary equations, roots only one roots, m equal to k. The solution of this equation is also c1 e की power kx. Choices is yours. First use करो या second use करो, choice is yours. x equal to c1 e की power x by method of separation of variable और method of solving of such type of first order differential equation. जो भी अच्छा लगे वो use करो आप लोग. ठीक है, x हो गया. Now t, for t 2 by t dt upon dt plus 1 equal to k. 2 by t dt upon dt equal to k minus 1. dt upon dt equal to k minus 1 by 2 t dt upon dt minus k minus 1 by 2 t equal to 0. Now, taking auxiliary equations, m equal to k minus 1 by 2, first order equation. In solving such type of equation, here only CF and pi equal to 0 means m equal to k minus 2. That's why t equal to C2 e to power k minus 1 by 2 small t. Second answer has come out. T equal to C2 e to power k minus 1 by 2. Now, first answer. Firstly, we assume the solution by method of separation of variable x of x, t of t. Now, both answer have been arrived. X equal to C1 e to power kx, t equal to C2 e to power k minus 1 by 2t, and u of xt. As we know that equation of order is first, only first order. That's why constant also be first. But here we see constant is 2, C1 and C2. Now, but in multiplying form C1 C2, which is finally resolved in one constant a e to power kx plus k minus 1 by 2 t. Now, final solution will arrive, but it is not actually final because condition is also given. So that just look at back. What is condition? Here condition is u x0 equal to 6 e to power minus 3x as okay. Yes. 6 e to the power minus 3x. Condition is given ux0 equal to 6 e to the power minus 3x. In equation 1, put t equal to 0 because it is initial condition. Initial means time t equal to 0. Initial कोई start ही नहीं हुआ था time t 0. So formatting of this equation, put t equal to 0 in this equation. U of x0 equal to a e to the power kx. Coefficient of t equal to 0. It's only left a e to the power kx, which is equal to 6 e to the power minus 3x. Comparing both equation, a, what is the value of a equal to 6 and k equal to minus 3. A equal to 6 and k equal to minus 3. Constant have been arrived. Okay. Put the constant in final solution. Six e to the power minus 3x plus minus 3 minus 1 2 by t. The final solution of this given partial differential equation by method of separation of variable is uxt equal to 6 e to the power minus 3x minus 2t. Okay. So by method of separation of variable, we have finalized the solution in the curve in the form of small x and small t. Okay. Now, next example, use the method of separation of variable for solving second order of differential equation. Earlier I have discussed first order differential equation. Here second order differential equation. Del 2u upon del x square minus 2 del u upon del x plus del u upon del y equal to u. Okay. Here independent variable is small x is named or small x and y. Now by method of separation of variable, we assume the solution u of small x y equal to capital of x f x into capital of y of y. means u equal to xy. Okay. Put the value of u in given differential equation. Where u have come out in the form of xy. We have put all the values of u, xy, xy, xy in all three terms. Okay. Now, operating the partial derivative in first term, second order, but second order of function of small x. So y is a constant. d2x upon dx square minus in second term order is small x means here also y is constant, and last term order is small y means capital X is constant. Now dividing xy in whole term for separating such type of equations. Y cancel, y cancel, x cancel. 1 upon x d2x upon dx square minus 2 upon x dx upon dx 1 upon y dy upon dy equal to 0. Now 1 upon x d2x upon dx square minus 2 upon x dx upon dx equal to minus 1 upon y dy upon dy equal to constant, which is taken as p square. Constant may be taken as anything, k, p square, minus p square, c, as you wish. Now, solving such type of equation in the term of constant, first, second. Now from first d2x upon dx square minus 2 dx upon dx minus p square x equal to 0. The second order differential equation in the form of capital X of small x. Now, solving such type of equation, we have to know that solution of this equation is in the form of CF plus PI. A method of ordinary differential equation, x equal to CF plus PI, right hand side equal to 0 means PI equal to 0. Only CF have been shown, and for CF, put the value of D in terms of m square minus 2m minus p square equal to 0, which is in the form of d square minus 2d minus p square of x equal to 0. Where d, put the value of m. For solving such type of equation, here no real roots. That means we have to put Sridharacharya principle for solving such type of quadratic equation. And what is the principle? ax square plus bx plus c equal to 0, x equal to minus b plus minus under root b square minus 4ac upon 2a. Plus minus b square minus 4ac upon 2a. M equal to 1 plus minus under root 1 plus p square. Two distinct roots. M equal to 1 plus under root 1 plus p square and 1 minus under root 1 plus p square. That's why CF means x, C1 e to the power 1 plus under root 1 plus p square of x and plus C2 e to the power 1 minus under root 1 plus x equal to c1 e to the power 1 plus under root 1 plus p square of small x plus c2 1 minus under root 1 plus p square of small x. X have been arrived. Now, for y, 1 up for y minus dy upon dy 1 upon y equal to p square. So dy upon dy plus p square y equal to 0. First order. So d plus p square y equal to 0. M plus p square equal to 0. M equal to minus p square. Y equal to C3 e की power minus p square y. ठीक है, तो u equal to xy, x equal to c1 e to the power 1 plus under root 1 plus p square of x plus c2 1 minus under root 1 plus p square x or y c3 e to the power minus p square y. Multiplying all constant c1 c3 a e to the power 1 plus under root 1 plus p square x minus p square y plus b e to the power 1 minus under root 1 plus p square of x minus p square y. Final solution of this equation in second order differential equation by method of separation of variable. Okay. For solving such type of equations, method of separation of variable is very useful method. Same. Another question. 4 del u upon del t, del u upon del x equal to thrice u, and condition is u equal to 3 e to the power minus x, e to the power minus 5x when t equal to 0. Here the function in the form of u of xt. Same parameters for method of separation of variable. X is a function of small x and t is small function of t, and putting all the values, and our equation now have been arrived this one. 4t dash upon t plus x dash upon x equal to 3. Separating up these equations in the terms of constant p square, the 4t dash upon t minus 3 equal to minus x dash upon x equal to p square. Now taking one by one. Firstly, we have to take 4t dash upon t equal to p square plus 3 from ordinary differential equation. dt upon dt 3 plus p square upon 4 dt. Now method of separation of variable integrating both sides. Now solution has been arrived t equal to c1 e to the power 3 plus 4 square by t. Now second solution in the term of x dash upon x equal to minus p square. Same method, solving integration in the form of integration log x equal to minus p square x plus log c2 and x equal to c2 equal minus p square. And both solution is in the form of u of xt equal to c1 c2 e to the minus px square x plus 3 plus p square by 4t, which is in the form of variables x of t of t. And the most general solution for comparing initial condition, that's why we have generalized this equation in the form of n equal to 1 to infinite bn e to the minus p square x plus 3 plus p square by 4t. Now look at the condition. Condition here is u equal to 3 to the minus x minus e to the minus 5x when t equal to 0. If t equal to 0, left side two terms have been arrived, but in right side only one term. That's why we have generalized this equation. So now from left hand side we have to see that's only two terms, means we have taken only two terms in right hand side b1 and b2. B1 and B2. Comparing both sides, B1 and B2. So B1 equal to 3, P square equal to 1, B2 equal to minus 1, P square equal to 5. The most general solution is equal to U equal to half xt, 3 equal minus xt, x plus t, and e equal minus 5x plus 2t, which is our final solution of this equation. Okay, that's end of this topic. Thanks.